All right, Ethan, let's have a look at this question here. So, question three, I've just done A, B, C, D. So, let's go now to E. I had a scan before. This is actually a pretty tricky question because there's a lot of things to consider here. So, what they want you to do is they say you want to reduce there's the cost that's involved here in this table, and what do we know? The completion time of each activity can be reduced maximum of 2 weeks. Again, it's similar to before. Overall completion time renovation to be reduced. Okay, so this is the difference. So 4 weeks at minimum cost, whilst before what I was able to do is I reduced essentially 6. So from a timing of 35, that's how long it takes, 35 weeks to complete the project, we've reduced it down to 29. So that means we reduced 6. But let's say you don't want to do 6, but you only want to do 4 weeks off. So I'm just going to copy this diagram to work with. So what we have as a problem is we're reducing too much now. So we want to only hit within 4 weeks rather than 6 weeks, right? And we want to do it at the best cost available. Now, the tricky part is as you reduce, there's so many different options that you can reduce and which one is the best. So what I do is I normally look at the cost first. So I'd say, all right, out of all the ones that I can definitely affect the timeline of 35 weeks, well then it's D, G, and K. Those are on the critical path, right? But in terms of the best cost to reduce, clearly I would want to reduce more of H's because it's only $1,000. And then number 2, second best is then D. And then G is 3. That's the third best. And then C is fourth best. So ideally, I don't want to affect K too much, but it is on the critical path though. So 5. Okay. So in my mind, what I initially have done was I did D2, G2, and K2. Now, I can't have that anymore because remember, I only need to reduce 35 down to 31. So ideally in the sort of D, G, and K, these are your critical pathways that can be affected. If I want to reduce it by 4 overall, okay, I don't have to do take away 2, take away 2, take away 2, because then that's taking away 6, right? Well, then I could do, say, D is 2, G is 2, and then say K is 0, right? I could do, say, maybe D is 0, G is 2, and 2. So that will reduce by 4. Now, the combinations that I can possibly get is quite a number, actually. Maybe I'll do it like this, so it's easy to see. So I'm going to keep that 0 and 0, so 2, 2, 2, 2. So that will all add up to 4. But I can also do things like maybe I can have 1 of each, and that's 2. Or I can have 2 in the center, then that's 1, 1. Or I can have 2 at the end, and that's 1, 1. So those are my main options. I don't think, because remember the maximum reduction is 2. So I think those are all the possible combinations that I can do that can get me 4 reduction. Is that right? 3, 3, cool. Now, just looking at this, $4,000. Actually, I'm going to do it in green. This is 2,000. This is 2,500, and this is 4,000. So I don't think I will go for like K being 2. So these ones here I may not look into, but just to be clear, I might try it. But those are probably the least combinations I'm going to try because 2 of these Ks makes 8,000. And I can see that 2 of the Ds will make 4,000 only, whilst 2 of the Gs makes 5,000. But the caveat here is that G, D, and actually maybe not K. K doesn't have anything else that I need to worry about. And what I mean by that is when we look at the network before, when we were doing it, what we realized is that when we subtract this by 2, right? A here takes 2. 2 plus 4 gives me 6, right? The problem is that if I subtract this by 2, that's now 6 plus 7 gives me 13. But interestingly enough, if I went up in this route, 6 plus 5 is 11, and 11 plus 3 is now 14. And you can already see that because C has 5 plus 3 is 8. And by minusing 9 by 2, it's 7, so it changes the critical part. So if you decide to change D by 2, it actually incurs an extra cost of having to reduce C by 1. You see, so even though this was $4,000, because it's $2,000 per reduction, times this by 2, you actually need to add on an extra 1 times, and I forgot what C was. C was $3,000. So really, there's a caveat here that this already adds up to, what's that, 4,000, that's $7,000, which is actually much more costly than reducing K. True? So if I reduce D by 2, even though it seemed like it was only 4,000, it actually ended up being more costly to do. 2 of the D's, 2 times of the D's is worse than actually doing 1K. See what I mean? But having said that, you then reduce the time by 2. So being mindful of the cost, knowing that D has a connection to C. Okay, so D, for every time you do a 2, there's got to be a 1 over here. So D, so there must be a 1 over here as well. Okay, so if you take it, and this is how I might kind of go about, so that means this has a 1 over here too. It means that out of the list here, I know that there are caveats. So D and C are connected, especially when I subtract by 2. And then, what was the cost for C again? That was 3,000. So 3,000. And then I got to look at G as well. The reason why I said K didn't matter is because by this point, K, if you reduce by 2, it doesn't affect anything else. You can't affect J. So K can be left as itself. So really, I need to focus on G now. If I subtract this by 2, that was the other one. What we can see is 4 plus the 2 gives me 6 to get here, but this is 5. So it looks like if I subtract this by 2, if I subtract G by 2, it would ultimately mean I have to subtract H by 1 to even it out, right? Because, again, 4 plus 2 is 6, so G plus I, so 4 plus 2 is 6, and the only way to match this is that this is going to be 5 at the end of the day. But if I take away 2, then it becomes 2 plus 2, which is 4. And then 4 means that I have to reduce H by 1. So it seems like, again, there's a caveat that if you reduce G by 2, so anytime you reduce G by 2, that means that H has to be reduced. Maybe I'll keep it as purple. H has to be reduced by 1. Okay, so there's additional cost here, and H costs you 1,000, which is more ideal. True? So ideally, you don't want to be reducing C as much, because every time not only are you costing yourself 4,000, like double of D is equivalent to 1 of K. True? So 2 of these D's is equivalent to 1 of these K's. And not only that, 2 of these D's actually cost an extra 3,000. So ideally, I can already see it's probably not ideal to do two D's with the 1C, because that's so much more costly than if I had just done 1K. True? So do 1K in terms of cost to match the cost, right? But it means that this looks like the worst case scenario to do 2 of the. Actually, no, the worst case scenario would probably be. Yeah, the worst case scenario is to do any double Ks. Double Ks would make it. So 2 Ks would make it $8,000. Okay, so that means I'm probably not going to look at this combination. I'm not going to look at this combination, and I'm not going to look at this combination here. Okay, because that one has the worst combination of having the most cost involved straight from the bang, when I could probably have reduced it by 2 Ds, 2 of these Ds, and then 1 of these Cs would already equate to, what's that, 4,000 plus 3,000, that's 7,000 in total. So if I were to go nuts, then yeah, 7,000 is at least a secondary effort. So I'm already seeing a couple of things here. We know that D and C are connected, and we also know that G and H are connected. Okay, so if I were to choose, I would avoid things of having too much. If I had to choose out of the all evils, right? 2 of these Ks is the worst case scenario because that's 7. That's $8,000. 2 of these Ds will end up with me getting plus 1 C, which gives me $7,000, right? But let's have a look at what if I did double G. So double G, we knew before, was that double G is $5,000 plus 1 of H, which is only $1,000 from memory. That was the cheapest one, wasn't it? Yeah. So that means out of all the evils, I'd probably be choosing anything with a double 2 for G. Okay, because it only costs you $6,000 in terms of its linkage. So right there, I would say eliminate, or not eliminate, but probably don't try this combination because there was the Ks, double Ks. Try not to do this one because there's, again, double the Ks, and I probably wouldn't try this one. I probably wouldn't try this one as well because there's not only the double Gs, but also you've got the double Ds there as well. Because remember, at the end of the day, I want to reduce 4, right? Which one is the best 4 at minimal cost? So it looks to me, I wanted double Gs, and this is a better one. The double G, whilst minimizing K and minimizing D, is probably the ideal, right? I don't want to have more of G and more of D or more of K. True? So I would say this might be the better option to try. It's likely the best option, but if we did that, right, let's go with this combination here. So 1, 2, 1. So that means D can be reduced by, say, 1, and then G is 2, and then K is 1. Now let's see how this affects C and H, right? Because that will give me a reduction of 4, right? So let's go back to our table here. Let's redo this whole thing again. All right, so if I were to I want 31, right? I need to reduce it by 4. So we said that maybe reduce D by 1, reduce G by 2, and then reduce K by 1, right? Because of the costing. This was probably the least worries to get the same effect of 4, reducing 4. So it looks like, what was this? Take away this by 1. D was the cost of 2,000. So I'm doing 2,000. But let's have a look. So A plus 2 is, that's 2 plus 4. That gives you 6. 6 plus 8. So, because minusing 9 by 1. So 6 plus 8 gives me 14. And then what's this? 6 plus 5. So that's 8 as well. So that means that C, which is great, you don't have to reduce it. Okay, because that will give you 14 as well. So both of them become a critical pathway if you do it that way. Okay, so that's 14. So that's great. We're going to reduce that by 1. So that only costs $2,000 to reduce by 1. That's good. That's very good. Didn't come with an extra cost. So I'm going to go back to the table. So that means C would be 0. And then let's say from 15, 14 plus 1, 15. And if I reduce G by 2, remember that has a caveat. H has to then be reduced by 1 from memory. Let me just double check that. Was that true? 2 plus 2 is 4. Yeah. So you have to reduce. So that means that 15 plus 4 is 19. So what's this? 15 plus 2 minus this by 2, so plus 2, 17. 17 plus 2 is 19. Yep. So 19 here, and then minusing K by 1. So wait, let me just write that again. So H has 1, so that means it adds on 1,000. And minusing K by 1, 19 minus, so that's plus 6, so that's 25, have I done that right? I'm rushing through this. 25, and then 25 plus 6 is 31. Yep. Okay, cool. So I still get 31, and it looks like I've minimized this. At least the $3,000 is not involved, so that's great. And I only spend one time a big amount of 4,000, right? And this one, remember, if I reduce this by 2, this is minus by 1, and that was the best case scenario of getting only $6,000 to get 2. Yeah, to get 2 down. So, and $4,000 obviously the cheapest one out of, if you want to reduce 2. So what I'm trying to say is, every time you want to reduce 2, if you did D, if you take away 2, the cost was that you had to add an extra C, which actually ended up being $7,000. If you did K, reducing it by 2, that works well, but that cost you $8,000. Then we found out, well, G, if you take away 2, that had an additional cost of H, which worked out to be $6,000, right? But remember, 1K itself is actually only equal to 4,000. So in terms of the ranking, this was the best option, and then followed by 4,000. See what I mean? So I'd say that we're choosing a pretty good pathway of 1, 2, and 1 there from what I can see. So if we were to add the cost together, what would that be? That's actually, it's probably easy to go back to this table. So it was C was 0 and H was definitely 1 when you do G. So C was 3,000, so that's $0. This was 2,000 for D, so 2,000. Double this was 5,000 because I think it was 2,500. Yep. Oh no, wait. G. Yep. Yep. And then H is 1,000, and K was 4,000. And so that gives me a total of what? 7, 8 plus 4 is $12,000. So I reckon $12,000 is probably the best case scenario. Yeah, I think that would be the answer to do this question. But that's how I might have approached it. I mean, you can probably test it by chucking in all of them, like by calculating them all. So I calculated this to be $12,000. I mean, you could try all of them. I mean, the next, if we didn't think that, we definitely know that doubling K is probably not the best option there. Because as soon as you do double G, that incurs an extra 1,000 there. So that's already 6,000 plus 8,000. That's already 14,000. Just looking at that. Double of this is $8,000. And then if you add double 2 of G's, that's 5,000 plus the 1,000. That's 6,000. So 6,000 plus 8,000, that's already 14,000. So clearly this is off the charts. And that's what I mean, that double K is a problem. But maybe the 1, 1, and 2. So this is 8,000. No, but then this is already 10,500 and then 12,000. Nah. See, even just this itself is a huge cost already. So it's 12,500. As in more, when I say huge, it's bigger than the 12,000. So clearly that's out. And if we quickly do this one, that's 8,000, right? But the double D adds an extra C, and we remembered that cost us $6,000. So again, 8,000 plus 6,000, that's already 14,000. So you can already eliminate the ones with the double Ks. Double Ks is not ideal. And if we were to do with this one, maybe 211, maybe actually. 2, remember double Ds will incur a C. I haven't checked if this incurs, but let's just see what the cost is at the moment. So this already itself is 6,000. Plus with this one is an extra 4,000. So that's already 10,000. 10,000 plus, that's already big. That's bigger than the 12,000. So yeah, it turns out that the 6,000 is a real problem. That's why. And then if we check the top one, that's 6,000 for double Ds, and that's already $6,000 there. And then this is $5,000, but we know that incurs an extra 1. So that's 5,000, and that's another. No, that's not 6. That's 7,000. Pwah, that's even worse, isn't it? This was 7,000 plus 11,000. Yeah, this was already way off. What am I doing? What I'm trying to say, I'm speaking my mind here, but double D's times by double D's, you have to include the C. That's already $7,000. So clearly, 7,000 with 1K in this option down here had to be out of the option, because that already gives you 11,000 plus the G. But anyways, let's go back to this one up here. Oh, that was a bad color. Let's just do. I might be babbling on right now, but hopefully you get my point, like how I went through it. But I'm just proving my point that I do think this is the best option here. So it'll be what 1. So D in itself was 7,000 plus 2. That's already big. So 2 Ds has to include a 1C, but then if you add double Gs, that's already 5,000, and we know that together this was 7,000. That's already 12,000 together, and that's not even including H. So, yep, I'm very confident right now. The answer must be $12,000, but that's probably how I would have done it. Ranking the cost first, like what's ideal, knowing which ones affect the critical path and how much did I want. And because I wanted 4, they said 4 weeks at minimum cost. I played around with the possibilities of D, G, and K, and that's where I got your 220, and then I just did the zeros then 2222. And we know that this was the most costly, so we can already eliminate those 2. And then when we looked at this, we had to look at, are there any caveats? And then we knew that D was linked to C when you minus it by 2, and if you minus this by 2, it actually added an extra cost of both. So it turns out, whilst this was cheaper, it actually wasn't the cheapest. And you do have to include K. Even though K was 4,000, it works out that a balance of them all was the best. And we figured 1, 2, and 1 because G was linked to H, which was the least amount of cost. That's why we went with 1D, 2 G's, and then 1K was actually the best option from what we can saw, because we saw that every time you did double D's, that actually gave you an occurrence of an extra 1C, which actually worked out to be 7,000, which is only the second worst, given that double K's give you already an 8,000. So that's one of the reasons why. Okay, so that's how I would approach it. I hope that helps you. I know it's a long video just for one part of the question, but I think it's to speak my mind so that you understand where I'm coming from and what I'll be looking at. So I probably would have finished it a bit earlier without trying all these other combinations. I might have left... Yeah, I might have tried these 3. So that's probably what I would have left with. I would have tried 2, 1, 1, 1, 2, 1, and then maybe 2, 2, 0. But yeah, usually the most balanced type of reduction is the best. All right, I'll leave you to it.